Well, this is the last mould for the day. It's the one I've been looking for about the last 4 hours. It's somewhat different. It's not actually going to have a drag part in the mould. Well, not really. What we're trying to make is this very solid lump of aluminium. It is a gang tooling block that's fitted to certain small CNC lathes. It's very difficult to get a lump of aluminium this thick cast with reasonable internal soundness. But what I'm going to do is cast it against this steel plate, which I will pre-warm in the oven first just to make certain it's good and dry. But then the thing will actually be cast against that, and this will chill the aluminium off and provide a decent, high integrity, dense, porosity free casting, I hope. But it's a bit of an interesting mould to sort of make. So we get rid of the steel plate for the moment. We won't need that until much later. Okay. Place that centrally like that. First, a little bit of facing sand. I won't use facing sand all over this, but the facing sand's a bit stronger than the backup sand, and it makes for a nicer edge on the cavity. Yeah, that mightn't be too bad. Just a little bit there. That'll look bad. The difficulty with a tall job like this is getting it rammed nicely right up the sides of the part. It's not very easy to do that, I've found. Now, just hold the part still to stop it moving around too much. I think the trick here is to ram in relatively thin layers. I also like to use a fair bit of sieve sand as I come up. I prefer the sieve sand against the pattern. I'm also ramming it quite hard in order to try and compact the sand nicely around the pattern on the almost vertical faces. That shouldn't be too bad, I hope. Make certain I ram it into those corners. At this stage we can probably put the riser in place. Whoops. Fairly big riser for a fairly big part. And in fact it gets a bit bigger later because I will extend it. Now, one thing I've forgotten, the more astute of you may have noticed, is a sprue. I need a sprue, and I should have put it in earlier. And very silly me, I didn't. I'll just cut that. Yeah, we'll be right now. Right. Now we shall have a sprue. Very careful there, I don't want to hit the pattern. It's only a 3D printed thing and they're as weak as all get out. They are really shocking. And generally speaking, I find them 3D printing things pretty useless as patterns because you can't get a good enough surface finish on them. In this case, because it's flat-sided, I was able to smear it all with car body filler and then sand it flat. Now, we might get a bit dramatic with the ramming at this stage. Make certain I poke it in underneath the riser. Right. Oh, my barrel of sand's getting a bit low, a little bit empty. Just put this on so I can get a little bit more sand in there. I think we still need a little more yet. We're not quite up to the level of the box, but we're getting pretty close. Now we're pretty much well above the level of the box, which is what I really want. Just remove this little thing. It was only there to allow me to get the sand a bit higher, a bit easier. I'll just roughly cut it down first up so that I can see the top of the riser. Loosen it. Pull it out with a screw, if I can find the screw. Here it is. Pull the sprue out too. Oh, it's a long sprue. That's only about 1/4 inch diameter down there, about 6 mil, I guess. It's up here at the top. It's got to be 12, 13 mil, I think. Something of that order. This is a 2 kilo casting. Oh. Now cut it down to the box level. Now I want to put some vents in this. I'll just put the feeder former back to make it easier to put the vents in. And a few perhaps right down around the outside as well. I've rammed this pretty hard and it may give me some trouble with the steam not getting out through the sand properly. Okay, that should do it. There we go. Clear away the sand and then turn the whole lot upside down and get the pattern out. Because we need a gate through to about here. There's our sprue, hiding down there. If I'd done it right in the first place, it would have been much better. Cut a gate. Use a fairly wide gate, I think. I don't know whether that's what it really needs or not, but it's what it's getting. Wouldn't mind that runner a little deeper. Yeah. And then round that edge off there where the runner connects to the gate. Okay. Now to get the pattern out. First of all, let's get it loose. If you're 3D printing patterns, you really need to think about where you're going to put things like a wrapping bar, because 3D patterns can be quite weak, and you can make them thicker and more solid, I guess, at one point with some careful thought as to where you need them like that. All right, that's not too bad. Now, put the screw in the middle. Give it a little wobble. And just pull it up, holding it against the steel all the way. Ooh, I thought you made it. Yeah, not too bad. Get them out of the way, that out of the way. Now I'll put this over in front of the furnace and put the steel plate there, and just before I pour these I'll warm the steel plates in the oven to about 200 centigrade, pull them out and let them cool down for about an hour, and then sit the mould on top of them and pour without delay. I'll now assemble these two moulds that are going to be cast against the chills, and then we'll see what happens. They've got to be fairly carefully placed, fairly evenly. That should be it. It's one. And here's the second. This one's even a bit more difficult to place. I think that's about right there. If I don't place them right, they might leak all over the bench. And now it's a case of hold your breath and hope, too, with the chill plate. Out of it. Thank you. She comes nicely. Okay, put that there in. Some exothermic on it. And the lucky last. Is it leaking?
Yep.
Oh,
everywhere.
rats! Oh well. Well, yeah, just come back and try again. Straight down the aisle. We might make it if we're lucky. It might have chilled off enough. Yeah, it might have. Okay, down to the ingot moulds. That one leaked a bit. Can't win them all. Okay, let's see what these are like. Oh. Yes, not by much. I'll just check that with the tongs to see that it is solid enough to get out yet. No. Sounds dull. Not like that or like that. It needs to be at least like that. It's getting there. This one, quite a bit more liquid yet. In fact, you can actually see liquid coming out the top when I tap it. That sounds better. That'll do me. It's not too bad. And there's the bottom half that's formed against the steel plate. Doesn't look too bad. I'm quite happy with that. Let's see if we can get it out of here. Whoa. Now, a hook and into the water. See whether the next one's ready. This is the one that leaked, so it could be a bit awkward. To say the very least, it's awkward. It's actually leaked through a hole in the plate. There we go. Oh, that's a bit of a bother. That'll make it very hard to get it out. Perhaps we'll have to take this one upside down, I suspect. That steel plate makes it just that much heavier. Looks like it'll have to go into the water, steel plate and all, I think. Right. Yeah, this is a hole in the plate right here. And it's just caught that. Oh, broken off. Well, that makes it a bit easier. Into the water. Now that these blocks have been cast and heat treated, all that remains is from the machined. Now, I've already machined the base of the block. And on this particular one I've also machined the top, and this sort of shows the advantage of casting against a chill. I mean, that metal looks like wrought bar stock, and it's actually a casting. Now, to get a casting this thick, this chunky, not only completely sound but completely free of gas bubbles, not bottles, really takes a bit of doing. But the chill they were cast against is a great help in doing that. A little bit of WD-40 as lubricant there. A little bit of air to blow away the swarf. Well, that doesn't look too bad to me. I think that'll do us for a finished surface. So that's it, job done.